So this is the ideal gas law, PV equals nRT. The units are a little bit different. Our pressure is going to be in pascals in physics, which is an unreasonably small unit of pressure. Atmospheres is much better, but that's okay, right? Our volume is going to be cubic meters. A cubic meter is 1,000 liters, okay? So if you get liters, you got to divide by 1,000, right? This is still going to be moles, right? And a mole is equal to grams divided by the molar mass, right? Okay. R is 8.31, okay? And that's joules per mole Kelvin. And why it's joules per mole Kelvin we'll look at here in a sec. And then, of course, this is temperature, and that must be kelvins, okay? That's like the biggest thing there, right? And then if I solve this for pressure, I can help you wrap your mind around this, right? If we solve it for pressure, pressure is how much you have times some constant to make it all work, times how fast the atoms are moving, divided by the space that they have to move around in, right? So obviously, pressure is the colliding of molecules, right? They bounce off the walls of the container, right? If you could draw pictures of these things bouncing, those are supposed to be molecules bouncing off the walls, like boom, boom, like that, right? The more you have, the more pressure you have. If you have twice as many, you have twice as much force, right? Temperature, this is the average, proportional to the average kinetic energy. The faster they move, the more they bounce off the walls, right? And then finally, the space, if you talk about the volume, the more space you've got, then the less frequent the collisions are with the walls, because most of the time they're traveling through space, right? So I tend to think of it this way, but however you want to think about it, right? As far as what R is, if you solve for R, R is equal to PV over NT, right? And then pressure is, of course, pascals, which is newtons per square meter, right? And volume is cubic meters, right? And then this is mole Kelvin. Well, if you look, you end up with Newton meters, which is a joule per mole Kelvin, right? Really, you should say pascals, cubic meters per mole Kelvin, but that's okay, right? So you should write all this down, right? Okay, so here, I'll write that down. Write this down. This is in case I didn't say it on the last page, right? Didn't mention this, right? Be careful of nitrogen, oxygen, fluorine, chlorine, bromine, iodine, hydrogen. I think there's one more. What's AT? I saw that on like a Wikipedia site or something like that. Okay, these are the diatomic molecules. So for example, nitrogen has a mass of 14.007 if you look it up. But since it's a diatomic gas, right, the mass of it per mole is, what is it, 28.014 or something like that. And that's grams per mole. Okay, so and the way to remember this, by the way, the very best way to remember this is none of Fred's clients bring iron hats. Yes? None of Fred's clients bring iron hats. Although if you say none of Flo's clients, I don't know. Anyway, this is when we say something's at STP, temperature is 0 Celsius or 273.15 kelvins, and the pressure is 1 atmosphere, which is this. Okay? I'm going to do an example problem. Pause and write these down if you need to. Oh, there we go. Yeah, a cubic meter. We're going to act this out in class, right? A cubic meter is an outrageously large amount of volume. It's 1,000 liters. Okay, it's 500 2-liter bottles. It's a lot. If you fill a cubic meter with water, you've got a metric ton of water. Okay. Okay, so let's do an example here, right? We're going to do PV equals nRT. And the way this is going to work is we're going to figure out how many moles it is, and then it says what's the mass of it, right? Well, we're going to figure out the mass from the moles, right? Okay. R is easy. R in this case is 8.31, right? Joules per mole Kelvin. Okay. That's easy. 37 degrees Celsius for temperature, right? That's easy, right? Because to turn it into kelvins, we go 37.0 plus 273.15. Okay, and that's the trick with ideal gas law problems. It's all just converting it into the right units to calculate it. That's the game that I play. It's the only way to make these difficult. Okay, so plus 273.15, 310.15. Ta-da. Okay, N is what we're solving for. The volume, 378 liters, isn't going to cut it. But if we turn it into cubic meters, it will, right? Ta-da. And that's cubic meters. That's kelvins. There we go. And then pressure, this is 90.1 psi gauge pressure. Okay, the first thing, I always turn it from gauge into absolute pressure. Then I turn it into whatever I need to turn it into. I don't know why I do that. Okay, so the absolute pressure is going to be 14.7 plus the gauge pressure, right? That's the absolute, right? So 90.1 plus 14.7 is 104.8, right? And that is PSI, right? And then I'm going to divide that by 14.7 to get atmospheres. I'm going to multiply by 1.013 times 10 to the 5th pascals, right? And that's going to give me the right pressure, right? So that divided by 14.7. It's like so many problems to solve. Okay, that times 1.013 e to the 5th. Oh wow, what is that? That's a lot. That is, I wish this stupid calculator would give me scientific freaking notation. Sorry, okay. 15 steps later, I get that it's 7.222 times 10 to the 5th pascals, right? So that's what I'm going to put in there, right? 7.222 E5 pascals. Now we're ready, okay? This is our ideal gas law problem. I'm going to solve this for n. So I'm going to go this times this, divided by both this and this, right? So that guy times 0.378 divided by 8.31 divided by 310.15. And I get a lot of moles, right? I get that N equals, I'll put it right here. I need like a space. I got to box it off. N equals 105.9 moles. Right? Okay. Now we want to figure out the mass, right? Remember that nitrogen, that is it. But remember it's N2, right? So that's going to be this times 2. Right? So it's 28.014 grams per mole. Right? So I'm going to multiply moles, right, by 28.014 grams per mole, right? So times and I'm getting 2.97 10 to the 3rd. And that's kilograms, right? Wait, oh, that's grams, right? So if you want to get rid of the 10 to the 3rd, you'd say it's that many kilograms, right? Yay. Okay, that's what it is. That's the deal with the ideal gas law, is just get it into the right units. This has to be pascals. This has to be cubic meters. This has to be moles. This you always use 8.31. Oh wait, joules per mole Kelvin, right? This has to be kelvins. It must be kelvins.